Visit with you guys a little bit here this morning as we pull you away from some of the content in Tremont. I have some things that we really want to share with you guys. Review some of our granular systems, some of the monitoring system capabilities that we have that we think can really help in your operation, as well as talk to you about some of the management and control options that we have as well. So I want to jump into that. I'm going to start with a picture of an air seeder. So a pretty simple tool that many of you folks use across the farm as you're trying to apply different seed, fertilizer, maybe seed and fertilizer alike. Again, pretty simple tool. We're trying to cover broad acres, right? Get a lot done, try to stop as little as possible so we don't want to have any issues. As we think about that tool, though, we know that as we're out in the field running, we've got some worries. In our head, we say, man, do I have blockages? Do I have an individual run blocked? Do I have an entire primary blocked? Did I run out of seed in one of those tanks and my system's not able to tell me that? I've got a lot of acres to cover, a lot of other things going on. So can I see those blockages? Do I have good visibility? I also worry about overlap. Typically this tool is going to be 30 to 60, maybe 80 feet wide. So as I'm going across the field, am I managing my headland pass as well? Do I have a good way to control so I'm not overlapping a significant amount, costing me extra money in seed, fertilizer, as well as yield and harvestability issues? Okay, so whether we're talking about a disc drill or we're talking about a hoe drill, or maybe you say, hey, I don't have this on my operation, or maybe I'm looking at striptill. I'm looking to add this to my operation. Again, I'm going to be applying a granular product, going to have some capabilities or potentials for some of those same issues. How do I monitor? How do I make sure that I'm getting the job done right? Okay, so our goal as we're applying these products, as many of you guys know, is we want to get the right product at the right rate, the right place, at the right time. When we do this, we want to do this across really every tank, every tower, as well as really every row of that machine, whether, again, it's a hoe drill, a disc drill, or we're doing this on some type of a strip till. Okay, so the goal ultimately then is if we're doing this, we really want to try to build the best yield possible. So if I'm planting my cereals, I want to make sure I get a fantastic stand. I want to make sure that I've got the right rate across the entire field. I don't want to have any lodging issues. If I look at my canola crop, again, I'm looking at, did I get the right number of seeds out there? Is my placement well? Do I get it all to emerge at one time so that I can manage one crop and not manage 3 or 4 different crops throughout the season as I'm spraying? If I'm looking at soybeans, maybe I'm using this type of a tool to get caught up on soybeans, or I don't have a planter in my operation today, and I'm using this tool to place all of my soybeans. I've got to do a great job as I'm going across the field. Finally, corn, not planting corn with this likely, but I am maybe doing some strip till or some fertilizer application, and that application is going to carry through all the way into my corn yield, right? Okay, so the reality is, as I talked about, there's some challenges here. I can have some secondary blockages, chunks of fertilizer, different things from rodents that are going to get into that. As I think about my system itself, maybe it needs a little bit of maintenance, or as those corrosive products go through like fertilizer, they cause a lot of issues within the meter. I have flowability problems, issues with my airstream, lots of things. If I look at my meter, a poorly calibrated meter or a meter that needs some maintenance, all of those things together can begin to really show me the reality, right? So if I don't have good visibility of that, when do I see this? I see it when the crop emerges. Is there anything I can do about this at this point? Pretty hard, right? As this barley came up, I found that I had some blockage and bridging in the tank. So as I came out of the headland, my fertilizer's there, but my barley's not there. Picture on the right-hand side is, of course, some sunflowers. So a drone view of sunflowers, an entire primary that wasn't getting sunflowers because they bridged in the tank. Again, by the time it came up, it's too late for me to fix this problem. Costs me money, hurts my operation. Well, what about fertility? Fertility is a little bit harder to see, so at this point, as this barley crop came up, I wasn't able to see the issues that I had from my pre-application. I went out early in the spring, I put down fertilizer, but my distribution was off. Without a good monitoring system, it was way too late for me to do anything about this, and very costly in yield. So I want to dive a little bit deeper into some of these challenges, give you guys some examples, and really walk through how we can help with that operation, that you have better visibility in the cab. So as we think about some of the systems that I've talked about already, some of the products that we're going to apply, right? We look as we go across pretty simply. Fertilizer is the first one on the list. Okay, it's commonly got some chunks in it. Maybe is part of the plant itself, maybe a chunk of wood or a bolt that fell out of the bunker. As you get that fertilizer, it makes it into the tank, and it causes some challenges as we get to the field. Inoculant can be pretty moist. A lot of bridging in the tank. Look at all of our cereals, especially a bearded cereal like our barley or our oats is going to bridge easily in the tank. So if we don't have a good seal on the tank, our agitators aren't working well, man, it can be a challenge. Okay? Field peas, soybeans, any of those bigger crops, higher rates, again, pretty susceptible to getting blocked up inside of the meter, inside the tank, wedging in places, causing us issues. Canola or flax, low rate that we're typically putting fertilizer with. To detect that blockage or to detect that flow issue can be a real challenge for us. And it doesn't give us the confidence as we're applying to make sure we're doing it right. So lots of tools we use. Again, on the screen you're going to have maybe your air tank with a tool, air seeder, strip tiller. Maybe we're applying it with a spreader, whether it's a spinner box or it's a boom style spreader. Or maybe we've got a drill, a box drill, relying on gravity to get it down through the tubes. Again, all these tools are going to present some challenges and some visibility issues as we get to the field. So as I was preparing for this conversation with all you guys, I said, man, I wish I could really represent a simple granular system. Okay, well, when I need a question answered, I go to Google, and AI at the top usually gives me an answer pretty quick. So I said, all right, AI, help me out. Give me a simple granular system. You can see it was a little bit challenging, right? So I had to do some refining. I had product coming out of a lot of different places. Got pretty complex, so I continued to refine, continued to ask it, worked with the AI model, and said, all right, get me to a spot where finally I'm here. Got a bin, I've got a meter, and I've got a distribution system below it. Okay, so this is going to be our graphic. I apologize for the remainder of this conversation, but hopefully you're going to get the idea. So this system is really doing two things for me on the farm, right? Okay, as I look at it, first and foremost, my bin carries my product. Below it is my meter. That meter is going to control the rate. So by a calibrated displacement and the speed that I'm driving, the width of my implement, and that calibrated displacement, I know how fast to spin that meter to get the product to flow through it. Okay, so my rate is then calculated that way, controlled by the meter. It drops down into my distribution system. Again, if I'm a spinner box or a boom style box, I control that belt speed, again, with those calibrations and values to get my rate to drop into my distribution system. Okay, so my rate is right, but now what about my distribution across the tool? Okay, just because I have the right rate at the meter, do I get it across the entire tool properly? So I drop that into my distribution system, whether it's an Airstream or it's spinners or it's a boom. I now have to make sure that that product is evenly applied across every foot of my width, every inch of my width, every one of my openers, every one of my drops. Okay, as I continue to make that more complex, typically I got multiple products, multiple bins. So I've now got one primary or one distribution system that's going to have 3, 4 products flowing through it, all that are different sizes, different shapes, different weights. They're going to flow different. They're going to be a lot different in how we distribute them, but I need it to be even across the entire width. Okay, so as I think about this, I go back to my childhood. When I was a kid, we had an International 620 drill. Okay, so when my dad got the drill out in the spring, we were ready to set rate on the drill. Okay, we went and he set the slider. Okay, more than likely the slider was set from last year, but we used that slider on the bottom and we adjusted how far open that gate was to go to the meter. Okay, now as Dad went through the field, how did he know that the drill was actually seating? Well, if he could see the chain, he looked at the chain. If the chain was going around, that meant that my meters were going around. It was dropping seed in the cup. He was seating. Okay, now did Dad make some assumptions? He did, right? Many of you in the room have made these same assumptions, right? Okay, so I assume that if my chain is turning, that I'm actually applying product. Okay, at the same time, I'm also assuming that every opener is getting product. Was that true? No, that was not true. Okay, so I look at today's cart control systems, what I have in the cab. I've got a lot fancier version of that chain. Okay, across my different monitoring systems, I'm going to have a readout in the cab that tells me that my middle tank is applying 120 pounds an acre. What is that really telling me? It's telling me that the chain is turning, right? It tells me that the chain is turning at the right speed based on my calibration. But it really doesn't tell me that I'm applying product. Okay? So if I think about it, I really need to monitor distribution as well, because this only tells me part of the story. So if I'm looking at distribution, I'm looking at flow monitoring, think about what we've had and what a lot of us maybe are running today is very similar to our early planter monitor. Okay, I had a system where if I was planting, the light was off. If I wasn't planting in that row, the light came on. Flow, no flow. Okay, very similar to what I have in a lot of cases on my monitoring system today in the cab. Okay, again, isn't able to tell me the whole story. So let's walk through a couple examples. I'm going to break this down real quickly just to make sure we're all on the same page. So I've got 3 bins. I've got a green, a blue, and a red bin. Each of those is flowing a product through into one singular primary system. That's my tubes across the bottom. And then I'm going to go out to a secondary tower, and each of those secondary towers is going to go to the run, to each of my individual rows or runs. Okay. Now, I only have one tower represented because I'd had to draw a lot more dots and it would have got a lot busier. So primary is into my secondary tower. At my secondary tower, then I've got sensors, right? These sensors are there to detect flow and give me information and feedback. So if everything is working correctly, my meter is spinning, it's actually dropping product into the stream, it's coming through the secondary through the sensors. My system, my no flow blockage system tells me flow. Everything's good, right? Okay, now let's throw some challenges at it. Now, if I talk about that fertilizer, some of those chunks that are coming through, maybe I've got high humidity, a product that's a little bit wet, tends to kind of block up things, cake inside of the header, cake inside of my primaries. Now I've got an issue at one secondary. Okay, so we go back to my example. I've got one sensor that's blocked off at a secondary. My no flow blockage system, what's it going to tell me? Tell me no flow. Okay, so at this moment, I'm in good shape. It has accurately identified a problem. I can stop at the right time, clear that blockage, get back to work. Again, I know that I'm up and running again. Okay, so as I move to the next scenario, what if I've got a primary distribution challenge? Hey, I cleaned the cart out last fall, but I didn't run the fan when I was done, and now I've got all that fertilizer that got moisture caked in there. It's got that primary completely blocked off, so I'm going to get no airflow through it. Maybe I put all my meters in, got pretty excited. We're going to seed the first day. I beat the neighbor. We're headed out. Hey, I forgot to open all the gates. So I get to the field. Again, in the cab, my meter says it's turning, but none of my gates are open. So in this case, even if my meters are turning, I'm getting no flow to the primary. My no flow blockage system in this case is going to tell me no flow. Hey, you better go take care of it, right? Pretty easy to detect. Now we know that those are easy challenges, but what if we throw a little bit more at it? What if we get a little bit more complex challenge? What if I'm looking at a hydraulic drive cart? In this particular instance, I'm going to get a reading in that cab. That 120 pounds an acre that this meter is putting out is based off of that sensor that you can see that's on the end of the motor. It's not on the end of the meter, it's on the end of the motor. So if my set screw falls out or my chain would run off, it would be possible that the screen would tell me that my chain is turning, but my meter is not. Okay, at the same point, I've got some sensors in the tank that tell me, is my tank empty or do I have product in it? Not always a perfect science, right? So maybe I missed that the tank was almost empty or my system's not working correctly. So one way or another, this meter thinks it's applying, but it's actually not. And so as I show my example, I've got nothing coming out of my green tank, no green flow. What is my no flow blockage system going to tell me? It's going to inaccurately define that I have flow, right? I have that feeling that everything's going great. When I'm all done, it's not. Okay, so that's pretty simple. What if I get a little bit deeper into some of those challenges? As I'm filling the drill, I'm up on the top, I drop a tarp strap in. Before I can get everything shut down and let Dad know, that tarp strap is covered up with fertilizer. Okay, so if I don't find it, or maybe I'm too afraid to tell Dad that tarp strap fell in, maybe the part of the fertilizer plant that made it into the tank actually chewed up my meter, and now the displacement of that meter is different than it was before. Or some of the corrosion that I've got on my meter has harmed my agitator, it's not working, pieces are broken, and I've got susceptibility for some partial flow on some runs. Okay, maybe I've got a partial rate blockage, I didn't get the tank lid sealed, the list goes on and on, right? Okay, so things that many of you guys have probably experienced, I hope not, but likely have in running this system. What is my no flow system going to tell me in this instance where my green tank has flow, but partial flow? Okay, my red tank, my blue tank, I've got all of those dots are out there, but you can see green is light. Again, I'm inaccurately defining that I have flow. So, comes down to the question of when I'm in the cab, when I'm placing this seed or placing this fertilizer, can I see it before it's too late? Again, in this case, I have no idea this was going on until the crop emerged. It'd be pretty hard for me to recover at this point. So if we think about measuring performance, something that we at Precision Planting have oftentimes talked about is we really can't control, we really can't fix a problem until we can measure it. If we don't know there's a problem, how do we solve that problem? That's really what we've talked about for the last several minutes. So we know that as we're thinking about monitoring flow, looking at it, giving you information in the cab, we need to be able to help you quantify row-to-row variability. And we need to be able to give you information about effective wear on components. If I've got an issue with a tank, or I've got issues with hoses that are worn through and I'm not getting proper flow. Is the system leak free? Do I have air leaks in place? Is my tank lid sealed? All these challenges we need to be able to measure better. And so again, if I can't see it, I can't solve the issue. So one of the products that many of you are likely familiar with is called ReconBlockage. Okay, so ReconBlockage, if you guys don't know, has joined the Precision Planting family. So we're excited to let you know that as part of part of our suite of products, ReconBlockage, is also with us. So as you're thinking about a system that you've maybe already purchased, or you're looking at purchasing the system, not only can you get support from the existing dealer that you've worked with, but also our Precision Planting Premier dealers also have availability to the product parts as well. Okay, so some additional support for that system. How does ReconBlockage work? We're going to use an acoustic sensor. And so we're going to listen for the flow to come through. We're going to feed that information into that module in the center. From there, we're going to interface with it on an iPad. Okay, so over here on the left on the wall, the right on the wall, you're going to see that iPad that's interfaced with the ECU or with that module that's feeding the information to you in the cab. Okay, so we're going to get information about blockages. We're going to get information about section variance as well as overall mass flow. So we're going to combat some of those challenges that I talked about. So what does it look like in the iPad if I have an individual run blockage? That first example I showed. I'm going to get alarms. I'm going to get a red spot on that primary showing me that that run is blocked. If I've got issues where maybe I've got a partial flow blockage, it's not going to show me row by row variability, but it's going to show me tower or section variance. A tower that's over applying or under applying, maybe due to meter setup or a partial blockage, as well as overall system mass flow. So if I didn't get the lid sealed tight or I ran out of product, if I have the alarm set right, I have everything set up, I should see overall system mass flow drop, which would alert me to something going on. Okay, so whether I'm looking at a tower system or I'm looking at a row by row system, or maybe I'm looking at a fertilizer spreader with a boom, I've got options through Recon to monitor and give you a better indication of what's going on. But what if I want more? What if I would like to be able to control? What if I want more visibility? Maybe I already have optical sensors on my machine today. I don't want to switch to an acoustic sensor because I already have this sensor existing on the machine. This is where we can add a 2020 to the cab as well as add this blockage module, and we can take that information from that sensor and give you more feedback, give you better feedback about what's going on the tool. Once we have that information in the 2020, we're also mapping, so from there we can send it into Panorama, and if I'm not the operator but I'm the owner and I want to make sure that things are going well, I can look in on the operator through Panorama and see how things are going. I also have information historically to go back to. Okay, so if I think about Clarity, say, I don't know, is it going to fit my tool? What options do I have? So many of you have that optical sensor. Excited to let you guys know or announce that we do have our own drop-in replacement for a Dickie John sensor. So if I'm running that optical sensor today, maybe I'm looking at a strip-till machine that's got a different size hose, we offer a 1, a 1 1/4, a 1 1/2, and a 1 3/4 inch sensor today. We'll have limited commercial release on a 2 and a 2 1/2 inch optical sensor as well. Okay, so really across anything that you're thinking from a granular perspective, we should have a sensor that would give you better visibility and unlock Clarity capabilities on it. Okay, so what does it look like in the cab when I run Clarity? What kind of information do I get? Let's start with magnitude. So this is a live example of a machine that was running a couple of falls ago. So when I look at magnitude, it's really a representation of flow. Okay, so it's flow through each individual sensor or flow at every row. So if I have higher flow, more particles or more product going through, my magnitude is higher. If I have less, my magnitude is lower. Pretty simple. Okay, we're going to use that magnitude information, and we're also going to give you a comparison of uniformity across the tool. All right, I talked about how uniform is my distribution. We're going to give you a metric right on the screen that tells you what uniformity is. Now, this is not a planter. We're not singulating, so I don't expect uniformity to be 100%. Okay, depending on the configuration of my tool, I feel like we should be closer to that 90%, but the more secondaries, the more different lengths of hose that we add, we're going to find more challenges in what that uniformity looks like. Okay, beyond uniformity, I'm going to have a deviation as well, so if I'm trying to understand what's going on in the drill, I'll have a deviation map to show am I high or am I low, and give you a really good visual representation to chase down some of those issues that we have. Okay, so when I'm looking at it again from magnitude, I've got a high, I've got a low row. I'm going to get an overall average of the machine. Across the bottom, my dashboard mini chart of my row by row view gives me a visual of every one of those rows and what my flow and what my magnitude is. I'm also, again, mapping that information, so it's easy for me to see in full color of what's going on in the field, and I have record of what that looked like as I made the pass. We'll talk about some downforce monitoring as well as some of our system monitoring here as we progress here through the conversation. But gives you kind of a look into what Clarity looks like in the cab. If you've got questions, again, we've got the stand over here on the right-hand side. We can walk you through some additional examples. So here's a partial blockage example from this fall, just to give you an idea. As I'm looking at this screenshot, you can see that row 27 is actually showing that it's a failure. Okay, so my failure alarm, I don't remember what my setting was, but as I actually blow that up for you, it wasn't actually a row failure, right? Row 27 had a magnitude. I had flow going through it. It's showing 1278 compared to an average of about 4,000. Okay, so after getting out of the machine and looking at what was going on, we went to row 27, actually found a small chunk of fertilizer caught in the boot. Wasn't completely blocking off flow, but it was blocking off enough that I noticed it on the sensor. Was able to remove that blockage, get back in the field running, everything was normal again. Okay, another example, I had a 60-foot drill running barley and starter, so 2 tanks at the same time. Working with the grower, initially starting up, trying to help him understand the system, understand some of the alarms. As we're going across the field, he had forgot that he needed to fill fairly soon, and he wasn't paying attention to any of his monitors or what was on his cameras for flow. So at one point, we started to get a few alerts on clarity. He's like, I wonder what's going on. He's like, oh no, I think my barley tank is empty. Okay, so on a no flow blockage system, fertilizer is flowing, barley is not. What is that system going to tell me? Tell me flow. Okay, now I figured out that I ran out of seed. I need to go back. How fun is it to figure out where you ran out of seed? Pretty challenging, right? Okay, most of the time we just try to find a spot, take the best guess at it. Now if I've got clarity and I've got mapping capabilities, I can see right there. That's where I need to start. That's where I ran out of seed. I can easily fill that back in without having a lot of extra overlap or a lot of extra cost. Last example I'll show you on clarity is a 42.5-foot drill as well. Worth the grower in the cab with them. We get started planting barley and a starter fertilizer. As we're going across the field, hopefully you're starting to feel a little bit more familiar with the system. So I'm showing you across the bottom right-hand side of that tool, every other opener is low on magnitude. My flow is low. Okay, so it looks like, as I'm going through some of the details, if I'm looking at my odd rows, my magnitude or my flow through those rows appears to be normal. But as I look at my evens, my flow is low. Okay, so something is going on. We stop at the end of the field. I go back and crank the crank on that ground drive cart. We look at the ground and we look at odd rows versus even rows, and I'll show you a picture of what we found. And does anybody see anything different between the odd runs and the even runs? There's fertilizer on the odd runs. There isn't any fertilizer on the even runs, right? So this again begs the question of, well, how is it possible? We're still sitting in the cab. We're a little dumbfounded as to how odds and evens are that way. But as we investigate further, we think about how this drill is set up. One half of my meter feeds my even runs. The other half of my meter feeds my odd runs. So after further investigation, pulling the covers off of the bottom, we found that we had a blockage in that front tank and we were not getting fertilizer through that segment of the meter. Without this system, how would we have found that? Probably when it was too late again, right? So I asked the question again of, can you see it? Well, if I add clarity to the system, now I can see it. As I was in the field making that pass, I knew there was something wrong. I knew that I had run out of seed, and I can solve that issue. I could solve that issue at the time that it happened. Hey, thinking about what else can we see through clarity? Is it just about flow and distribution, understanding rate? No, we can also look at downforce. So as I'm planting through the field or as I'm getting set up with my seeder, where do we set this needle? Somewhere between the top of the orange and the bottom of the red, right? And we're close in that range. Now, does that guarantee that I'm getting the seed in the ground? Doesn't. Okay, so if I think about how do I understand whether or not I'm actually getting the gauge wheel to contact the ground, that I'm actually at depth? Well, we add a load cell. I've got a John Deere disc drill. I can add a load cell to some of those openers, and I can actually monitor what my ground contact is, so I know that I'm doing a good job of getting the seed in the ground. For this year, we're also going to add a compatibility with some hoe drills as well, some different Burgos and Seedmasters and a Vaderstad. In this case, we're going to actually replace the hub of that packer wheel with a load cell. So now that packer wheel is part of our depth system. We're using that to maintain the depth of our seed shank. If we lose weight on the packer wheel, we know that we've lost depth, right? So if we know that, we could then manually increase that pressure control to make sure that we're doing a great job throughout the field. A couple of last things just to make sure on smart plugs. Some of you guys are running the system already. These system-wide monitoring is going to give us information in the cab like tank pressure. An easier way for me to tell, do I have the lid closed? Do I have the correct amount of pressurization between the meter and the tank? What about my work state? In the past, we've had a challenge a little bit with our work state. We now have a way to read a potentiometer so we can accurately control when we start and stop the system. And also fan speed. It's table stakes, right? We need to be able to see what that fan speed is because it plays into our distribution and rate and blockages across the machine. So one of the things that we look at is 26.1, or our new layout. Okay, so many of you in the room have hopefully seen this. There's a couple of stands along the right wall that's going to have this new layout in our new software. That's a whole new dashboard that's redefined for you to be easier, a little bit more dynamic, easier to resize. But one of the things that we're really excited about in the granular space is we've reintroduced a tower view or a BXM view that would be module by module. So in the situation like that 1890 drill I talked about, where I had a tower that was low in flow, I would have found that a lot faster because that tower would have highlighted and been low in flow. Something you can see as well over here on the stand as we take a break. So again, along with that, we talked about panorama. The data comes through the panorama, so I can monitor what's going on in the field. I can go back and find some of those troubled areas. I can understand maybe later on in the year if I had an issue, was there something going on that applicator or on that seeder that I didn't notice at that time. So really, Clarity is going to be the backbone of that system. And we're going to get good visualization, good monitoring. We're going to give you great information in the cab about some of the issues that you may have. Okay, now that we have great monitoring, we can talk about solving and managing some of those problems. Okay, so we think about managing performance on our cart. We have either a ground drive cart typically, or we have a hydraulic drive cart. If I've got a ground drive cart and I'm out trying to make rate changes, how do I make a rate change on this ground drive cart if I've got a transmission like this? I exit the cab and I need to use that handle to make that rate change. And the graduations are pretty easy to see. There's 5 lines in between on that little aluminum gauge. So pretty hard for me to make an accurate rate change. If I'm trying to apply a variable rate prescription, and if I don't have the electric pieces here, or I've got that windshield wiper motor that turns that, how fast are my rate changes? Pretty slow. At the same time, I've got to make sure that everything stays lubed well. Now, if I put a 2020 in the cab for Clarity, very simply, I can add to it a rate module. I can add a seating motor. We offer the brackets and all the sprockets and all the parts to add this motor to my cart. So I can convert from ground drive control to a hydraulic drive. When I convert to that, then applying that prescription, executing those rate changes is going to be a lot easier because I make that change through the cab. I calibrate through the 2020, so now I'm monitoring and I'm controlling all in the same screen. Now, if I'm looking at a 1990, as well as I've got a hydraulic drive cart that already has the hydraulic drive on it, we do have brackets for 1990s as well as harnessing to convert my hydraulic drive 1910 to run everything through the 2020 if I choose to do that. If your machine's not listed up here, I've got something different. I've got a striptill applicator I want to monitor and I want to run through the 2020. Talk to your dealer. We have availability to control other hydraulic drives as long as they meet some of the constraints as it relates to the valve type and some of the sensors that are on there. Okay, so what about, we have rate control. What about swath? Today when I lower my air seeder, typically I'm going to turn around at the headland of the field. As soon as it's straight behind me, I'm going to get it down, right? Because it takes 3 to 4 seconds for seed to start flowing. Now, if I could control every headland pass better, I can add with that rate module that I already have to control the hydraulic drive, I get full meter swath. So now instead of me guessing when the drill needs to be down, I just get the drill down and the seed starts flowing when it needs to start flowing. The fertilizer starts flowing when it needs to start. Now if I have sections on my tool or I've already got hydraulic gates, I can add a swath module to that system as well, and that swath module will control those gates. We aren't going to monitor any gate sensors, but with Clarity, we shouldn't need to monitor any gate sensors because we have visibility of what's going on at the opener. Thinking about downforce, I showed you we can monitor downforce. What if I want to take control of that downforce and hand it over to the 2020? Through seeder force, I can either add rank control, take readings from that load cell, give it a target of how much weight I want on that gauge wheel to maintain depth and ground contact, say you take care of it, you monitor it, you control it. I can do that either by rank or I can do that by individual row control on a John Deere disc drill. So as I do that, I remove that needle valve. Now, as I think about that opener, I'm maintaining ground contact. I'm also potentially saving some wear and maintenance on those items as I'm not over compressing, I'm not pushing hard on that gauge wheel, carrying all that weight. Last thing that I think about here is what's on the same side of that gauge wheel? My closing wheel. That wasn't a trick question. Okay, so if I'm putting extra compaction underneath that gauge wheel on that soil, my closing wheel has to work that much harder to make sure it can close that up and destroy what I've left over from my furrow. Okay, so if I can manage my downforce well, I can manage my closing a lot better. So we talked a lot about management so far. Now I said, hey, AI model, I want to refine this system. So give it a shot. So as it pulled up the next few images, this is what I got. Okay, so pretty interesting. I've alerted the engineers in Tremont. They don't have to worry about AI coming for them yet. As you can see, it numbered up to 8, but there's actually 9 there. Okay, so I'm still a little reluctant. Everybody feels safe back at home. Okay, so what we do see here on this system is a couple of things. Now I've got individual control of those primaries. Okay, I got individual control of rate, as well as it looks like every one of those primaries can measure and meter itself. Okay, so likely I'd have some individual swath, I'd have some capabilities that I'd really like to have. Okay, so when we think about refining the system, there's some challenges that we wanted to overcome, challenges that we know you guys want to overcome, and that is we want to reduce coverage overlaps. And we want to increase rate accuracy, and we'd like to eliminate those meter corrosion issues. There's nothing more frustrating than having a system that doesn't work because we've got fertilizer that's harming it, we've got holes, we've got issues there. So we want to try to eliminate all those things. So exciting today. You guys will be some of the first ones to see it. Over here on the right-hand side, we want to show you our tower-by-tower electric meter concept. Okay, so with this tower-by-tower electric meter concept, we're going to give you tower-by-tower rate control. We're going to give you tower-by-tower swath control, and we're also going to give you primary blockage monitoring. Okay, so what's the system look like? I look at the beta cart that we installed this last fall. I'm taking a cart existing that's got meters that need some maintenance, that have served their time, they've got some corrosion issues. I'm going to replace those parts with stainless or composite parts that are resistant to corrosion. So I'm going to replace them once, and we should be good from there. Okay, so as I do that install, I'm going to remove everything from the bottom of the tank. Everything low of the tank to the funnel coming out of it, I'm going to take off. Okay, I'm then going to put our own stainless steel funnel inside that attaches to the ladder. Below that is going to be my actual meter frame. The meter frame is going to contain an electric drive agitator. Okay, so if my meters are turning, my agitator is going to spin. If a meter is not turning, my agitator will stop like you'd expect. Gates below to service any of those meters. From there, I'll install the actual meter assembly into that meter frame. So if I've got 6 primaries, I'll have 6 meter assemblies. If I have 8, I'll have 8 meter assemblies. So as the product flows down through the tank, past my agitator, it'll flow into those meters themselves. A couple of connections that we make on the back side of that meter we're going to hook up. That's going to give us power and communication. Currently in the beta on the front side is where we're plugging in our primary blockage monitoring. Okay, we intend to move that to the back if we can, so both connections are in the same place, but we are making those 2 connections for power, communication, as well as primary blockage monitoring of each of those meters, each of those tanks themselves. Okay, so if I need to do some meter service, if I need to do any swapping, I need to pull things out to clear any chunks or any blockages, I'd be able to close the gate on that individual segment, give that cap a 90-degree turn counterclockwise. I'll pull the auger out. From there, I can clear anything out of there. If I needed to make a change over for a crop, I would also be able to do it that way. So easy to service, easy to put back together. So again, as that crop flows through, as I'm coming from the tank down and through, I'm going to come into the inlet of that meter. Underneath the inlet of the meter is going to be our auger. We'll have, intending to have 2 different rate augers, a higher flow option and a low flow option for rate. Behind that auger then is going to be a butterfly valve. That butterfly valve is going to be there to really control and make sure that we don't have any spillage when we don't want to. So if I'm commanding rate, that butterfly valve will be open. If I'm not commanding rate, that butterfly valve will close and it will block off my distribution system from the meter. Okay, that's all going to be monitored with an integrated blockage sensor that you'll see over here on the stand. So all that flow will go down through that blockage sensor. Again, as we control it, we're going to do all of this with one motor. Okay, so that butterfly valve is going to be controlled by the same motor that runs the auger. I'll show you how that works in just a second. But we're going to have also a sensor to make sure that we know what is the position of that butterfly valve. We don't want to feed product if the valve isn't open, right? Okay, so how does that drivetrain work? Again, using that same stepper motor. When I make a rate command to turn on, I'm going to give that motor a counterclockwise turn 90 degrees. Through a one-way bearing, it's going to change, it's going to move that gear train, and it's actually going to open that butterfly valve and immediately start rotating the other direction to actually meter that product. When I tell the system I make a rate change and I command 0, I'm again going to stop turning clockwise. I'm going to make a quick counterclockwise turn 90 degrees, close that butterfly valve, and wait for the next command. Okay, so as we look at what kind of results did we see from running this in the field, what kind of capabilities do we have? So again, tower by tower electric metering system, we add to what we already have for a secondary blockage monitor. We again give you a tower by tower rate control. Okay, so this means that every one of those individual towers could have a different rate. Hey, it could unlock capabilities to have turn compensation. It's going to give us a better way to calibrate, as I only really have to calibrate one segment if I want, and I can apply it to the rest. Or I can calibrate the entire thing. Again, from Swath, now I've broken my drill down into smaller segments. I can better control what that overlap looks like in the field, as well as I can actually time it out correctly for my hose lengths. Again, meter and primary blockage monitoring to add on to that secondary system to help us detect issues earlier and figure out where they're coming from. Now, if I've got tower by tower rate, as I look at applying prescriptions, my top example here is a full system-wide, so full tool-wide meter. So as I make a rate change, this prescription's in 20-foot increments. Now, as I make that change, it's going to have to go full drill width. Right? So if I got a 60-foot drill in 20-foot increments, I'm going to choose that middle rate and apply it. Now, if I go to this type of a system, I have this electric meter. Now I can be much more precise as I control that prescription. Now I can be on 8, 7, 8, 9-foot sections instead of that full 60-foot width or full 40-foot width, depending on your tool. Okay, so again, dropping down from 60 feet down to 7.5, having the ability to time those meters out so that I don't have any issues with longer hoses or shorter hoses. My drill should turn off and turn on very close to a straight line, depending that I have all the settings correct. So I have a lot of capability there, as well as the advantages of having full tower by tower swath. Okay, so whether I'm a square field where I'm just trying to manage the headland itself, making sure that it's turning on at just the right time and it's turning off at just the right time, or I'm planting at an angle. Maybe I'm planting into sunflower stalks, and to clear that residue well, I'm going at an angle. I'm applying fertilizer at an angle, applying my winter wheat at an angle, or I've got a really odd-shaped field. Or maybe, just maybe, you decided that you wanted to show off to precision planting, and you were going to put our plant logo in your field. Great way for us to control and make sure that we have very little overlap in these situations. Okay, so just kind of as an example, as we're still trying to quantify some of the numbers, as you think about your operation today, when you go to buy seed and fertilizer to put out with your air seeder, with your granular system, if you don't have any type of a swath system, my conversations with most of you, I'd say you would look at probably a 10% overage of what you plan on for acres. Okay, so if I look at this example of this system, this is a drill that just has granular rate control, so no metering system on it, like what you see here right of stage. We're just controlling the entire meter itself. So this field, sprayed by a Symphony nozzle sprayer, works out to be 90 acres of coverage. Now, as I plant this with a drill, I go back out there again, this is full meter swath, so one section, I'm looking at planting about 6.8 extra acres, so 7%. So just by controlling that meter itself and going full tool swath, I can save roughly 3% alone. Okay. Now, if I take it to the next step and I look at what about some of these angles? What about some of these areas of the field where it's not just a straight dead turn off? Okay, as I look at panorama and I start to capture some of that, looking at just this one end of the field, because the other end is pretty straight, right? But this end of the field where I came across, I actually overlapped each of these passes about 1/4 of an acre. Okay, so 43-foot drill, 26 of those angled passes. Just on this alone, it's about an additional 1.35% of overlap that I'd have in the field. Okay, so at costs of starter urea wheat that are on average in this field, I'd have saved about an additional $1,000 on top of the 3% that I already had, right? So when I look at swathing by primary, this is what it's going to look like with our electric drive metering concept. As I leave the field here, I want you to note that the meters that are on your right are going to spin for just a minute. And it's because my coverage wasn't quite completely covered. So in between the gap of my two headlands, I needed to turn on. Okay, so I don't want you to be confused by that. They come on because there is a skip or a gap in between there. So as I take off, you'll see that a couple of my meters are firing, and you can see in my magnitude map that product is being applied because I have a skip there. So as I come out of the first headland, you can see my right-hand meter starts to turn, and as it works across, each of those individual meters will start spinning on cue based upon all the settings that I have to make sure that I have good coverage, but I'm minimizing the amount of overlap. Okay? So if I look at that example again, this particular instance, a 44-foot deep bander that we're applying some fertilizer with, this field was 318 acres. When we looked at it again, pulling into panorama, a little bit different angle than that last drill, but if I look at what that overlap is here, again, I'm at about 1/8 of an acre per each of those passes. Okay, so probably a little bit more expensive blend of fertilizer that I'm putting down here. In this field I saved again about an additional 1.5%. So now we're at 4.5% just in this spot, not accounting for anything else, not accounting for the other end. Again, I'm saving about $1,000 here as well. Okay, so those are just preliminary numbers as we're trying to quantify and really figure out how we want to show you when we have a partial flow of product, because we never turn clean off with an air seeder, right? Our distribution and the way our metering system works, it's never a dead stop. We always have a little bit of a trickle that comes out after. So we'll continue to share those results with you, but I wanted to give you that information as we have it. So the last thing I think about as we look at overlap is we get to the end of the year, we get to see what our cereal grains look like, our wheat crop, our barley crop, any of those areas where we overlap. And I show you on the right-hand side, I've got an arrow going through the pass that you're looking at. As I'm coming out of the headland, if this is a full 43-foot drill, I'm going to have 43, 44 feet of overlap there. What typically happens to that crop? As I'm driving around looking at my fields right before harvest, is that crop standing proud? It's lodged, it's down, it's going to be hard to harvest, it's got some potential for disease, it just makes things more challenging, and it costs me in yield, right? So if I can also take care of the seed, if I can take my savings from seed and fertilizer as well as manage my crop better, have better harvestability, I think that means a great deal to you guys as well. So what's next? You're asking, how does this system look? What are we looking at? So we're going to continue beta testing for this spring. We'll go through the spring of 26. We'll run it through some more scenarios. We'll get a few more miles on it, make sure that things are ready. Things go well, we're targeting a limited commercial release for this June of 26. Okay, so we'll talk to your dealer, keep updated with them as we continue to get some miles on it. That's really what our roadmap is from this point moving forward. So again, as we think about measure, monitor, control, if I'm looking at how do I monitor my system better? How do I have better visibility of flow? I want to add clarity. Maybe downforce, maybe managing my depth is something that has been a challenge for me, and I want better visibility of that. I can add cedar force. Okay, maybe we're looking at how do I control my meter better, whether I'm looking at a full rate control or I'm interested in something that this electric drive metering system provides. 26 looks pretty promising for a lot of those solutions. So I would say talk to your dealer, let us know what questions you have. And we'll have the stand up here running. You can turn it on and off, see the butterfly valve open and close. You can tear a meter apart, really look at what it looks like. Again, I will caution you to remember that this is a beta meter, so these parts could look different as we get to this release when we get to the summer. In fact, I promise you these parts are going to look different because these are the parts that ran in the field this fall. Okay, so absolutely look at it, ask us questions. We do have a cedar maintenance guide. If you guys have questions on maintenance, I will leave this QR code up for you for your John Deere disc drill. It can help walk you through some of those things that we want to look at.